Okay, I guess I'm recording. Maybe the sound was not on. Make sure that is on. Okay, so we're covering 8.5 today, guys, where we're classifying the 3D figures. So the big things, we'll go over some vocabulary. A prism has two bases, okay, that are congruent and parallel. The bases are not always the bottom, but this right here is a triangular prism because the two bases are parallel from each other. That means they'll never intersect, and they're congruent. So here is a 3D figure that is just like that as well. See, the bases are the triangles for this one. A pyramid has one base, and it meets up at a point, and the sides meet at a point. Notice the point for the pyramid. Cylinder, the prism, it's a circular base, okay? The cone, again, the base is a circle, but it meets to a point. Meets to a point. And then we have your sphere, which is the ball. And I have shapes. If you ever feel like that you need to look at them to help you to understand, you are welcome to look at this, in which each point is equidistant from the center point. So all around from the center of the circle, it is equidistant all the way around. All right, so now we're going to kind of think about naming and how many sides are there and all kinds of other fun stuff on here. Okay. Get some of the stuff that we're going to use regularly out of the way. Okay, so for number one, we want to classify each solid. Well, the first thing to be able to do that, we're going to also look at the faces, edges, and vertices. Well, when I'm looking at this, this is called a rectangular prism, which is what looks like this right here, okay? Because when I'm looking at it, this could either be a square prism or a rectangular prism. It depends upon how you look at it, what the base is, what they shade as the base in the 3D figure. The rectangular prism is kind of the easiest, but sometimes also the most confusing when you're thinking about it. But it is, I think it's the easiest one because it's just always a rectangular base. Every side is a rectangle. So here is a rectangular prism. How many faces? The faces are all of the sides of the figure. So we have the left and right, the bottom and top, and the front and the back. So based on that, that was 3 sets of pairs. So that's 6 faces. Edges are where all the faces connect. So I have 1, 2, 3, 4, 5, 6, 7, 8. Vertices are all the corners where the edges meet. 1, 2, 3, 4, 5, 6, 7, 8. Oh, wait a minute. My edges are not correct. I just counted here. 1, 2, 3, 4, 5, 6, 7, 8. But what about here? 9, 10, 11, 12. Because I've got to connect everything together. So my edges were wrong. This is 12. You can also see and count on the figure itself on the drawing. Now, we're looking at this figure here. Well, we know based on our definition, it comes up to a point, so we know it's a pyramid. We just have to figure out what type of pyramid. The base is what names it. Okay, so we're going to come up here and I'm going to add a little note right here. Base shape names 3D figure. So when I'm looking at this shape right here. It's got 1, 2, 3, 4, 5, 6. And it's the side opposite the point. So therefore, this down here is my base. It's got 6 sides. So therefore, this is a hexagon. 6 sides. So that's hexagon. So this is a hexagonal pyramid. Okay, so now I can count from the figure. So it takes faces. Well, I've got the bottom, and then I've got 1, 2, 3, 4, 5, 6. 6 triangles along the sides, and then the bottom. So that's 7. You can't see it just on the shape, then I've got figures, but we've got the bottom, and then I have the triangles for each side. 1, 2, 3, 4, 5, 6. So there are 6 lateral sides, and then you have the base, which makes 7 faces. Now we've got the edges. Well, I've got all the edges along the base. So this is 1, 2, 3, 4, 5, 6. And then I've got 7, 8, 9, 10, 11, 12. So therefore, there are 12 edges, and I've got to figure out the vertices. 1, 2, 3, 4, 5, 6, 7. So there's 7 vertices. Okay. Let's go through this a little bit faster. Now, this is where the prisms can kind of throw a little bit. You got to pay attention to what's the parallel sides. Parallel sides on here. Here's my base with this triangle here. So this is a triangular prism. So how many faces? 1, 2, 3, 4, 5. Because I've got this one here, the top, and then the bottom. Edges. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 edges, and then I've got 1, 2, 3, 4, 5, 6 vertices. Okay, next page, you're flipping this right over. Now we're going to talk about slicing. The figure. Okay, so if I'm going to take something and slice the 3D figure. So when you slice a 3D figure, the cross section will be 2-dimensional plane. For example, when a cone is sliced, parallel to its base, shown to the right, the cross section, which is the shaded region, results in a circle. So given each figure and a cut line, draw a diagram. So we have to draw a diagram of the cross section from a top side view. That means looking at it from the top. All right, so let's look at number 16. When I cut it straight across, what's the base shape? It's a triangle that looks like this. So therefore, I draw the cross section, and then I need to also name it. So we draw a diagram and we name. 17, ooh, this is cutting down. Well, when I look at that, that's actually going to do a triangle shape, because it's cutting down this way, then it's cutting down this way, and then it's going across. So therefore, that cross section is another triangle. When I'm looking at this one, I'm cutting it right here, but what's my base shape? A rectangle. So our focus today was the 3D shapes, naming them and classifying them with the vertices, edges, and faces. And then what's the cross section going to be? Have a great day.